Hello guys, welcome back to the new video. So what we are going to see today. So today as we saw the conditional probability in last lecture. Okay. So today we are seeing the conditional probability satisfy the three axioms. Okay. So first thing is conditional probability satisfy three axioms. I'll also write that three axioms. As we know in the starting, the three exams that's basically these exams are also the same, but the thing is a little modification. Otherwise, all the remaining three is means generally they look like the same only. Okay, first non-negativity. All of you know that non-negative. Here in previously we saw that probability of a greater than equal to zero. Here in this side I'll write the previous one and this side I'll write the new one. But here P of A given B is greater than equal to 0. The second one is normalization. Previously we saw that the probability of total sample space is 1. Here we are doing just a little bit modification. Okay. If you want to prove them, then also we can prove it. Like how we can prove it? We can write this by this. Okay. And we know that this intersection is P of B only. Now this is one. Okay. So we prove that this is the second one. This is the first one. Now what is the third one? In previously we saw that third one is for the mutual exclusion. Oh, sorry, mutual exclusion, not but mutually disjoint. Okay, like that here also we can write if here A1 and A2 are mutually exclusive, means there is A1 union, A1 intersection A2 is 5, means there is no common for here A1 and A2. So then we can write like this, as you can see. Okay, now if anyone wants to prove, then also I can prove here. So if we are expand this, then what we are getting? We are getting A1 union A2 intersection B upon P of B. Okay. Uh, okay. Let me tell you by using the Venn diagram only. So this is our A1. This is our A2. There is no common between A1 and A2, and this is our B. Okay. So A1 union A2 intersection B. Okay. Let's this is A which is common. This is B. Okay. I think you got it. So A1 union A2 intersection B will be P of A union B upon P of B. You can check it. There is no common thing here. So that we are merging these two, and the common with B is this part from here and from here. Okay. We can also, because we know that A and B both are disjoint, we can also write like this. This is our LHS. Now let's change to RHS. Let's say whether we are getting the same RHS as LHS. So P of A1 B plus P of A2 given B. A1 B means A1 intersection B upon P of B plus P of A2 intersection B upon P of B. So this A1 intersection B means this A only. So P of A, this is P of B and upon P of B because common denominator. I think You got this clearly. Now, this is what the conditional probability satisfy three axioms. These are the three axioms which I am talking about. So, please, guys, if you're making the notes, then just note it down by pausing the video because I have some page problem. So, I am removing this and writing the new content in this only. Okay. Sorry for the inconvenience and thanks for the support. Okay. Now we are moving to our next topic, which is total probability. I think if you many of you know about the total probability, but let's understand how it's work and how we can find the total probability and why we need to find a total probability. Okay, let's say this is our sample space. In this is our event B. So we want to find the probability of B, but we can't, let's say we don't have any information about the event B. It means that we can't find directly the probability of this event. So what we can do, let's say we have this type of division, which is, let's say this is event A1, event A2, event A3, event A4. So we don't have a direct way to find the probability of B, but we have a division. So from that, what we can say? So here, from here, we can say that we have a four division. Okay. So with the help of this four division, we can find the probability of B. So for the B, what we can say? For the B, we can say B intersection A1 a union. If you want to find the B, B intersection A2 union B intersection A3 union B intersection A4. So the first one is this, then this, then this, then this. Like that, you can find the B by getting division. Means you are dividing into the four sub-events, and from that you are finding for the event B. Okay, and here we can say that A1 union A2 union A3 union A4 is our sample space. Yeah, sample space, right? Okay. Now what we are doing? So to write above means like this. If you want to write this, we should have all the AIs as mutually exhaustive means covering all the sample space. I think you understood this. If you want to write like this, then this A1, A2, A3, A4 should be mutually exhaustive. Means it should cover all the sample space. It's not like that there is some part which is remaining from the sample space by doing the union of these two, union of all the AIs. Okay, so the important thing is that if let's say we have a three partition division. If A1, A2, A3 are making a partition, A1, A2, A3 are making partition, then what we can say? If for writing this, what are the conditions? So first thing, let me tell you. If let's say this is our sample space and we have, yeah, let's say we have event B. Now we have a partition like this. I think you are understanding. One, two, yeah, this is a two, this is three, this is four, and this is five. Now in one, this is let's say one. This part is coming. This is a two. This part is coming. This is three. This part is coming. What might possible? There is a one partition like this, in which all the common thing is coming. Okay, so here we are counting the probability twice. So for that we have to put some condition for making the partition. Means we have to specify some rule. Based on that, we can check that rule for the partition. And what are the rules? So if they are making partition, then this A1, A2, A3, okay, what about that, are mutually exhaustive, as we know that it should cover all the sample space. And the second thing is they should are mutually disjoint. It means there is no common part between A1, A2, A3, A4, means any of AIs if we get it from partition. So this is the rule, and this is called as total probability, or in terms of machine learning you can call it as marginalization. Remember, this is for ML student, because all the computer science students are the ML students themselves. Okay, so we can write for event B, or we can say that the probability of B is P of B intersection A1 union B intersection A2 union B intersection A3, and we know that all three are mutually disjoint. So we can write in terms of plus B intersection A2 plus P of B intersection A3. Like that we can do. This is our P. This is the probability of that event that we want to find. So I think this is clear. So let me do the conclusion for this part only, which is called as the total probability or marginalization. So what we saw here, if we have any event but we directly can't find the probability, so we want to find based on the partitions given. So what are the conditions for the partition? The union of the partition should be the sample space. It means it should follow the mutually exhaustive property, and they are mutually disjoint. So if, because they are mutually disjoint, so that we can find only a single time probability. So we don't need to go for the twice. And so if they are mutually, so we can write from here to here. I think this is clear to you. Okay. And now let me do one thing. First, let me remove this, as I told you my problem with the system, so that I can use only this space only. But in the next lecture, I will solve that problem. And let me, this is the main formula that we can see for, I think it's visible, yeah, it's fine. Now here also we have a different type of formulas that if you want to remember, then you can remember it. Like here also we have inclusion exclusion principle. What's that? If we want to say E union F given B, it means we can write P of E given B plus P of F given B minus P of E intersection F given B. And also here we have a De Morgan's. Yeah, you can check the spelling. Here we are not for the grammar checking. E intersection F complement given B. Okay, you can write E complement union F complement given B, and vice versa thing also means here if you have a union. Okay, let me write it also so that you will not be the confused person in the room. Okay, so this is the complement here. If we have a union, then this part will be intersection. I think this is clear to you. Okay, So here we saw the inclusion exclusion principle and the De Morgan's law. Okay, now let's do some example of the conditional probability and also of the total probability. Okay, in this video or in the next video, I'll come up with the example so you don't have to worry. Okay, and these examples are very easy to understand also for you. So let's say what we have three. Okay, let me put it three bags. Okay, first bag is B1, second bag is B2, third bag is B3. Okay, let me do uh, in first bag we have 75 red and 25 blue. In second bag we have 60 red and 40 blue ball. In third bag we have 45 red and 55 blue ball. Let me put this into the bag also. Okay, this is a very interesting question. You like this. And if you like this video, then do subscribe. आग लगा दो. Okay, now what we have to find. So what we are doing here. Choose one of the bag. Please listen the question. Choose one of the bag and pick a marble from chosen bag. Okay, what we have to do? Pick a marble. Marble, ball, all are the same thing. Okay, let me write here. Ball only. Pick a ball. Also, then what is the probability that chosen ball is red? What we have to find? We have to check chosen ball is red. So what we have we can do? So this is our solution. So if you know the solution, you can write it in the comment. You can write the method. This is for the total probability. Hmm. So let's for selecting the bag B1, we have a three option. We can select either of the B1, B2, B3, and for all we can use a 1 by 3 probability. In B1, getting a red bag or getting a blue. B2, same red blue. B3 also red blue. Okay, what is the probability? I think this is a very easy question. If you find any problem, then just let me know. I think to solve this question for the people who are not understanding, because this is really easy question. Like we have a three bag, so selecting a ball from one of the three is 1 by 3, and in each bag we have probability of getting red is 75 by 100, because we have total 100 ball in each, 100 in each. Okay, so 75 by 100, so 0.75, like that. If the ball is not red, then it's blue. Like that we are doing. Now chosen ball is red. It means from the first this, now from the second this, and from the third this. These are the probability. Just do the summation and we are ready with our answer in 2.45. Okay, if you are doing, you will find zero point 0.6 last at the answer. Okay, you understood the problem? Okay, now let's move further. If you find any difficulty or you have problem with my methods also, like I am going fast or slow, you can write it in chat. Don't worry, I'll here for you only, guys. So if you have any problem, you can discuss with me. I am very happy to solve your doubts. Okay, let me do. So now I am about to end this lecture, but before ending, let me give you a two problem. That's very good if you love to solve. And next lecture you have to come up with the answer. Okay, let me tell you what's the problem I am giving to you. I think you'll enjoy this problem. So, what you have to do? These are the two statement I wrote here. You have to tell me whether the first one A and the second B. You have to just write true or false. You have to tell me whether first is true or false and the second is true or false. Okay, I'll give you the time of 1 day and I'll solve this question in the next lecture. Okay, so I am ending lecture here. So if you like the video, then do like and do share with your friends. We'll meet in the next lecture with the solution of this. Thank you guys.